Okay, so we're going to talk about now some of the part 2 questions. These are the 2-pointers. I'll bring this down a little bit. There we go. 2-pointers dealing with quadratics and operations using polynomials. Okay, first one. We start to take a look at what's going on. It says solve. And once again, the thing we're going to focus on is we're solving for this, and it has an x squared. So if it has an x squared and we're solving, we're going to have to factor. So we're going to have to try to factor this up into, break it down into a couple binomials. So the first thing we have to do, if you remember, is we have to get 0 on one side. So I'm going to take this and I'm going to subtract 7 from both sides. I'm going to bring down the result. I get 4x squared minus 12x minus 7 is equal to 0. All right, so now this is a quadratic that we've had a little bit of practice with, but not a lot. The leading coefficient is 4. So there is no greatest common factor, which would be nice to be able to take out in this case. So we're going to have to break this up into two binomials. And the place you're going to start with, guys, is we're going to start with the fact that we're dealing with 7 because 7 is prime. And I know if I multiply these two numbers together, the last, I get that 7. So I'm going to put a 7 here and a 1 here. I know those are the two factors that we have to use because the only two factors are 7. Now, when I look here, I have a 4x squared. So I know I'm going to be dealing with an x and an x. The big question, though, is 4 has a couple factors. We can use 4 and 1, or we can use 2 and 2. So you're going to have to just try to guess which one is the most appropriate. When this number is not that very big in between, I would shy away from the bigger difference, and I would go with two numbers that are kind of closer together. So I'm going to put 2x and 2x. And what I'm going to do is, I know I'm going to get 7 with the L, and I know I'm going to get 4x squared with the f. I know that. So what I'm trying to get is I'm trying to get this minus 12. And where does the minus 12x come from? It comes from the outer and the inner. So the outer has a value of 2x, and the inner has a value of 14x. So is there any way I can get 14x and 2x to become 12x? And the answer there is yes, because the signs here are going to be different. And I want it to become a negative 12x. So I want the 14x to be negative, so it's a negative 7. And I want the 2x to become positive, so that's a positive 1. So it's going to be factored. So I'm going to have 2x minus 7 times 2x plus 1, and that has to equal 0. I take each factor, and I set it equal to 0, and solve. It's not going to look nice, but guys, this is algebra. We're good. So we get 2x is equal to 7, divide by 2, divide by 2. I get x is equal to 7/2. And over here, I'm going to subtract 1. 2x is equal to a negative 1. Divide by 2, divide by 2. X is equal to a negative 1/2. So my solution set here is just simply going to be x equals 7/2, comma, negative 1/2. And just make sure you read the question, that they don't put any restrictions on your solutions, and you're done. Okay, question number 2. Question number 2 says factor the expression, and they use the word completely. Now, we're supposed to remember that when it says factor completely means we are going to have to probably factor more than once. This is x to the 4th. Don't let that confuse you. It's x to the 4th followed by x squared followed by a constant. This takes on the form of a quadratic. So this is going to factor into two binomials, and we're not solving for it, we're just factoring it. Instead of having x and x, when we're dealing with x squared, we're dealing with x to the 4th, so it's going to be x squared and x squared. That's all. That's just the change. All right? Now, we look at the signs, and the signs are determined by this last number. This last number is negative, so my signs are different, and it doesn't matter where you put them because we have a 1x squared and a 1x squared. And then we're looking for factors of 7, and there are only two of them, 7 and 1, that add up to be 6, and when the signs are different, it's really they subtract to be 6. But I want the 6 to be positive, so I need to put the 7 here, and I need to put the 1 here. All right, factor completely. So that's the first factoring technique. I look at this binomial and ask, do I have a GCF? No. Is this the difference of two perfect squares? No. Is this a quadratic? No. I take a look at the second binomial. Do I have a GCF? No. Is this the difference of two perfect squares? Yes. So I got to do one more factoring technique. So the first binomial stays. This binomial breaks up into 2. x and x by definition with difference of two perfect squares. 1 plus 1 minus, and then the square root of 1 is 1 and 1. And we're factored. Question number 3. Question number 3 says, in the equation x squared plus 10x plus 24, so x squared plus 10x plus 24, they factored it into x plus a and x plus b. And they say find algebraically all possible values of b. Well, one thing we're supposed to know is that when I multiply a and b together, I need to get 24. So the possible combinations of a and b are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Those are all my combinations. Once I take a look at all my combinations, I have to remember that if the signs are the same and they're both positive, I'm going to be looking for numbers that will add up together to give me 10. And when I take a look at these combinations, the only numbers that add up together to give me 10 is 4 and 6. So if I take this out, this is telling me that I could have x plus 4 times x plus 6, or I could have x plus 6 times x plus 4 since the signs are the same. Which means here's your b value, here's your b value. B could equal 4, or b could equal 6.